Okay, good evening. Welcome to
Minute Math number 3.
MinuteMath number 3. This is another one of our contest problems that we saw on the Mathematical Association of America's website. And these are contest problems for high school kids and junior high kids that they're putting out there. And I think they're fun to go through with younger kids and just see how you solve them. So here we go. Company sells peanut butter in cylindrical jars. You know what that means?
What is the jar's a cylinder?
The jar is a cylinder. Market research suggests that using wider jars will increase sales. If the diameter of the jars is increased by 25% without altering the volume, by what percent must the height be decreased? So they're going to make wider jars that are shorter and have the same amount of peanut butter. Okay? So they're going to shrink the jar and make it wider so you have the same amount of peanut butter in each jar. And then we just have to figure out if you make it wider by 25%, how much does it shrink? Okay?
Yeah.
So the first thing you need to know is the volume for a cylinder. Volume is pi times the radius squared times the height. Okay? Does pi r squared look familiar?
Yeah, that's the formula for the area of a circle.
That's the formula for the area of a circle, and you get the volume by just saying you have a circle that's tall. Okay? Times the height. Okay? Here's the height. Hope this shows up well on camera. Now, if you make the diameter 25% bigger, what happens to the radius? So here's the diameter, and if you make that 25% bigger, what do you think happens to the radius?
Well, the radius gets bigger also.
By how much?
By 25%.
Also by 25%. What's the relationship between the radius and the diameter?
Well, the diameter is 2 radiuses.
The diameter is 2 radiuses. So if you make the diameter 25% bigger, you make the radius 25% bigger. So we need to, what is 25%? What fraction is 25%? Do you know?
It's 1/4.
It's 1/4. So one thing we're going to do here that I'm going to show you, kind of a trick to solving a problem like this. We're going to choose numbers for the radius and the height to make the problem a little bit easier. So if we're going to increase the radius by 1/4, we want to pick a number for the radius that's divisible by 4. So what's a good number that's divisible by 4?
4.
4. So let's say the radius is 4. And what's 25% bigger than 4? What would be the radius over here? If I make the radius 25% bigger. What's 25% of 4?
It's going to be 5.
5, right. Okay. And I want to pick a height that's nice, and we're going to what percent must the height be decreased by? What number do you usually associate with percents?
Well, 100.
100. So let's make the height 100, okay? So the first volume is pi times 4 squared times 100. Okay?
Yep.
And the second is volume, which is exactly the same as pi times 5 squared times question mark. What do you want to call this? X?
Yeah.
X. Okay? So this is volume, this is pi times 16 times 100 equals pi times 25 times x. Okay?
Yeah.
So we can solve for x. We divide by pi. What happens to the 2 pi's?
They go away.
They go away. Do we have an eraser around anywhere? You see one?
There's one over
You run and get it over there? Right, so the pi's go away. And I get x equals 16 times 100 divided by 25. Okay, do you know how to make that simpler? 16 times 100 divided by 25?
100 over 25.
What's that?
4.
What's 4 times 16?
64.
Hey, look at that. So we just found out that this height is 64. Well, that's nice. And the question is, by what percent must the height be decreased? If it starts at 100 and it goes down to 64, how much did I decrease the height by?
You decreased it by 36.
By 36. So I have to decrease the height. If 100 decreases by 36, it has decreased by 36%, right? Because 36 over 100 is
36 over 100 is 36%.
36 over 100 is 36%, so we got our answer. So the way we solve a problem like this, one way to solve a problem like this, first we need to know the volume formula. If you don't know that, you can't solve the problem, right? I just told you that. Then we picked some numbers that made the problem easy because it said it worked for any jar, right? So we just pick one that makes it easy. We picked 4 for the radius because we're increasing it by 25%. 4 turns into 5. And we picked 100 for the height because we were trying to find out what percent the height must be decreased by. So that makes our life pretty easy. The height went from 100 to 64, so it decreases by 36%. And we're happy, and we're done, and bam! Not too hard of a problem, right?
Yeah.
Pretty good example for problem solving. All right, good job, sweetie. Good job.